Okay, to my people that are absent or the people checking out this video later, right now, they're in the back of their homework spirals trying to get 5 out of 5 right. Or at least 4 out of 5 or 3 out of 5. Trying to get out of the 1 out of 5, 2 out of 5 range. We're trying to get as many right as possible in the back of our homework spirals. The name of the game is multiply, and I hinted at tables, arrows, mental math, solve. Tables, some of you call them graphs. Arrows, foiling. Mental math, can you get all 5 perfectly right? Do it the way you need. Do it the way you need. Ready, set, go if you have not yet already. Oh. And let me go fill in the people in the video as to what I told you guys in the class. All right, kiddos joining us in the video. We were talking about how, come on Andrew, get all 5 right. You can do this, you can do the tables. We were talking about how test corrections are due today. If you need an extension, obviously all of you that are gone today, you're not turning them in today. Have them ready tomorrow or come talk to me if you need an extra extension. But the end of the grading period is Friday. We need to get these corrections in for your extra points. The fires have messed us up a little bit as well as minimum days. So if you haven't gotten them done, come in to school, lunchtime, period 7, or after school, whatever day you get back, and I can help you finish them. Test corrections due today. Evers, get all 5 right. Come on, you can do it. Get all 5 right. Doesn't have an eraser, Jerry, but I think it has lead. All right, come on, rock stars, get all 5. Well, hopefully. These tables, we know how to do. Thank you, Sean. We appreciate it. Well, I think he's doing like the arrow method. But you said so. Wait, so is this like boiling? Yeah, boiling, evil. I see about half. Half of you are doing like the arrows, or at least the boiling idea, and the other half of you guys are doing the table. Now careful. I'm just slowing a couple of you down that might be doing the mental math and getting it wrong. Okay? This one's x squared plus 5x plus 6. Do you get all the pieces?
Oh, I got it.
Okay.
What if it's in different order?
Then it's okay, but it wasn't in standard form. So remember, you always want to take your answers and write it from highest degree to lowest. He has a squared, he has a single x, and he has none. So that's the descent. But yeah, you're good multiplying. You can still count it as right. It just wouldn't have been like the best form to end in. So that's okay. Yeah, what's wrong?
So when it's 2 numbers and no x, we multiply?
Just multiply like normal, yeah. But that's what we're doing anyway, right? X times x is x squared. 2 times 3 is 6. So we're just multiplying. Trying to old-fashioned foiling multiply. See if we can get them all right. Okay, I'm so close to wanting to write down every single answer, so try to finish up if you haven't gotten all 5. Now, if you haven't, by the time I start writing answers, if you haven't gotten them all done, it's okay. Try to get 3 out of 3. Try to get 4 out of 4. Try to at least see if the ones you did do, you got right. Okay? What we're doing today, remember our, well, hold on, let me erase the pre-calculus on the board. That's very confusing. Right. What we're doing today is starting section 7.5. There were quite a few of you guys absent yesterday, so we graded homework, but I didn't walk around and check it because I knew there were going to be a lot of absent people. So I'm going to check homework today on the worksheet and on the bookwork from section 7.4. But we are in this warm-up getting ready for today. Today is factoring, but it's factoring, well, we'll see the title. It's factoring basic polynomials. And I'll show you what that means in just 1 second. Just the basic idea. But first of all, we're seeing how our multiplying is going. So a quick review. If you're done and you're making sure that you did them all right, if you're doing the arrows, you would have had x squared plus our foiling, outer, inner, last, which is how we got to that final answer, if you're doing the arrows. If you're doing the box method, we can double check your answer and make sure you got it right. You would have had your x squared, your 7x, your 4x, and your 28. These ones are nice because so far, 3 plus 2 is 5. No one's going to make a mistake on that, at least not many people. 7 plus 4, 7x plus 4x is 11x. Not many of you would make a mistake on that. But remember, when the signs start changing, 1 positive, 1 negative, 1 negative, 1 positive, then it gets trickier because some of us are negatives are hard. So I gave you some kind of basic ones. Just to see, do you remember the arrows, do you remember the tables, whatever way you used to solve. But here we go, let's get the rest of them. You ready? You guys, tell me, let's see if you're right. What'd you get for number 3? X squared plus
16x
good, plus
55.
Got him. How about number 4?
X squared minus
Minus 8x. A few of you the negatives got you tripped up.
plus 15.
Plus 15.
Oh, plus
Why?
15.
And negative 3 times a negative 3 is a positive, no, negative 3 times a negative 5 is a positive 15. But negative 3x plus negative 5x is negative 8x. A few of us, the negatives are messing us up. Last one, x squared.
Minus 8x plus 7.
Give yourself a score. 1 out of 5, 2 out of 5, 3 out of 5. I only did 3. Okay, 1 out of 3, 2 out of 3, 3 out of 3. Give yourself a score. Make it a fraction. How many of you guys, with however many you tried, got all of them right? 3 out of 3, 5 out of 5, 4. Look around the room, guys. Awesome, right? Awesome. How many of you guys, well, hold on. Keep your hands up if you got all of them right or you only missed one. All of them or you only missed one. That's like, yeah, a huge majority of the class, right? Okay. So multiplying. Can we do it? Yes. Are there still little mistakes we might make? Yes. Let's see if there are any harder ones because I couldn't fit them all on.
Uh-oh.
Oh, I think you guys could do this all together like mental math. Can we try mental math? You ready? No, put pencil down, pencil down, pencil down. Don't have to worry about it. No table, no arrows. I want you to go straight to the answer. X to the power of 2, x squared. Minus 12.
X.
X.
Oh, nice.
Plus.
Plus 32.
Have to multiply. Good.
Oh, yeah.
Pause. Do I want all of you doing mental math multiplying
No,
on
you
tests?
No.
No. No. But, is it possible for some of you to think about it and maybe almost get to the right answer every single time without doing a lot of work? Yes. Okay. Why am I telling you this? Because, ready? In the beginning of chapter 7, when you did all of the foiling and all that jazz, and the boxes and the tables, you were going from, ready? Let me write it down. This side is factored form. were going from, remember Moses in the Red Sea, how we split up the factors if it's equal to 0? Factors, they're the guys in parentheses. They're the guys being multiplied to make something bigger. In chapter 7a, you were going from factors. Wait a minute, what's the big word of our chapter? You were going from factors to, who are all these guys? Products, I mean, it's the multiplied. Can I give you one name? Ready? Caleb, this way. No, okay. Polynomials. Now, these are all trinomials. I know, they're all trinomials. Maybe I should have said that. But when you multiply, you guys remembered, weren't there the ones that had like 2 by 3 or 3 by 2? They were the bigger ones, like the bonus on the last test, right? I'm getting these corrections in, and I'll give you your next or your last test. I have all your tests in now. So that way you guys can work on corrections on that one. Let's get this test in first. But you were going from factors to polynomials. Now what does factoring, look. What does factoring do?
How would you see it?
Well, that's what the homework is we're about to check. I'm going to have you guys get your worksheets out in a second and the book work that we can grade today. But remember yesterday, didn't we, hold on. Andrew, you're right. GCF is what we were doing, right? Yeah. So hold on, let me give you like a super basic problem. Like the worksheet. Did you guys notice in the middle of the worksheet there was something that just said, I think, was it simplify? You were just getting the factors. You were just simplifying, not solving. And there was something like 4s cubed minus 8s. What were you supposed to do? Hold on, wait. Is this factors? Look on the screen. Is this factors or is this a polynomial?
Polynomial.
Yeah, it's a polynomial. There are no parentheses. So check it. Now look back up here. Who's your GCF?
S.
S is some, yeah, that's the variable, but what's the constant that's in common?
4.
See it? Does 4 go into 4 and 8? Yes. Does S go into S cubed and S? Yes. What do we do with that GCF? We divide it. Good. We write the parenthesis. Oh, look at the factors. Okay, look back up here. Parenthesis. What do we write outside the parenthesis? 4. The 4S. Good. This is us factoring out the GCF. Okay, what's left inside? Someone said divide, and you're totally right. What's left when you divide this by 4s? Not just 1s. If you need to, take this guy off to the side and write him out. If we take away a 4 and an s, what's left?
S squared.
See it? S squared. Minus. I can take this guy off to the side. 4 goes into Everest and Andrew. It's hard. Focus.
Yeah.
If I take away 4 and S, what's left? 2. Okay, pause. Alexis, check it. In the homework that we're about to grade, the worksheet and 7.5, or 7.4b, that's going to you guys missed 21 through 38. As I grade that, you are going from, ready? Polynomial to factors. How is that different than the ones that you just aced? You were going from factors to where? To polynomials. You were going this direction. Right? Multiplying goes this direction. But what are we doing now? The same thing, but not forwards. We're going backwards. Just check it. Factors to polynomials, and in the homework that we're going to be grading, you're going from polynomials to factors. So guess what? If factoring out a GCF is going from a polynomial to factors, what do you think section 7.5 is going to be? We are going to be factoring out x squared plus bx plus c. We're going to be going from trinomials backwards. Look, we're going to be going from this side back to that side. Factoring polynomials. We're factoring trinomials. We're going backwards here. So section 7.4 was just going backwards with a GCF, and that's it. But section 7.5 says, okay, Now let's take some of these ones that you guys just showed me. You're doing awesome on going forwards, and let's learn how to go backwards. Now, you might be like, what's the point? Do you remember, let me just give you a peek. Do you remember how, in the beginning of, grab out your worksheet. Doesn't your worksheet around numbers, 7 and 8, doesn't it give you a graph? Now, we did a graph yesterday, and some of you weren't paying attention, like you're doing now. And so you got to the worksheet, and as I walked around and I tried to, as many of you guys as were stuck and just staring at your worksheet, didn't I stop by your desk yesterday and say, okay, let's get you to do 1, let's get you to do 2, right? I might not have made it to everybody, but I made it to at least 3/4 of the class, trying to at least get you somewhere through the worksheet. Some of you were like, I didn't know what to do with the graphs. So look at the worksheet, right? Look at the worksheet. Look at the graphs. What were you supposed to do when it said, figure out where the graphs hit the axis? You were supposed to come to the graph and say, okay, where is this? And I told you yesterday the name of it. You don't need to memorize it yet. But Andrew was helping us out. It's that x squared guy back there. It's called a parabola. Yep. Oh, pause. This one. Stop. Okay. So with the math dance, we have our parabola hitting the axis in 2 different places. Last year with Miss Sutherland, you guys learned how to graph lines with I need a point and I need a rise over a run. That's enough. But if you look at this guy, if I give you a point, there is no rise over run to get the graph. A parabola is going to be much harder to graph. And that math dance poster is helpful for Algebra 1, for Algebra 2, for pre-calculus, for calculus AB, and for calculus BC. Whoa! That's used a lot, right? No, so is factoring. But coming back. These little intercepts are super important in lots of different ways. And I can't even explain all of them to you because you don't know enough math yet, but that's okay. I just need you to realize that these, what we call zeros, are super important in all of those classes. Okay? And these classes are ones that you need to, at least some of them, need to take for SATs, need to take for college entrance exams. Like, no matter whether you're like, I'm going to stop math soon, these zeros are super important. So, to get these zeros, these zeros are easy. You just remember, we can do the zeros. You see if it's equal to 0. Wasn't that the beginning of homework? You see if it's equal to 0. Then what? Moses and the Red Sea. You take each one. And you split it up. And you set equal to 0. But wait. We can only take each one if it's written in what form, guys? I can't do Moses and the Red Sea unless I have the factors. So check it. If we're given this, which is the normal standard form of the parabola that Andrew's looking at back there, he's looking at the easiest one, x squared. But more normal ones have all 3 pieces. If we're given this, and those zeros are so important, we cannot find his zeros unless we can take him and write him in that factored form, which for us is going backwards of FOILing, backwards of the table, and figuring out who are the pieces that fit in here. That's section 7.5. I was telling all my calculus kids today, because they have like these required tutoring hours. You have some calculus kids on your teams or in your friend groups or in your grades. I was like, they are starting to learn factoring, and they're like, oh, it's that big of a deal. From Algebra 1, factoring is one of the biggest topics that kids need to learn. And the better you learn it now, the better it is for you later. And I told them to tell you that, and I was like, hey, offer to tutor, because factoring is something you've had to ace, and some of them didn't learn it until Algebra 2 or pre-calculus, or some of them are still rusty on it in calculus. It's not that hard. It's just that important, and some of you minimize the importance of it because you don't understand. So let me just tell you now, this whole section 7.5 is crucial, super important to being able to move forward in math. So we're going to go back to section 7.5 in just a second. We're going to get into our notes in just a second. But you guys did so great in multiplying, and I'm so proud of you for that with the FOILing, the table, whatever you did. But now we need to learn how to go backwards. But pause. We have a worksheet, yeah? Here we go. Worksheet. Let's go ahead and peek at the worksheet from yesterday. But really quickly, those of you guys that were absent, can you raise your hands? Because I'm going to come around and get you a worksheet. Of course, since you were absent, it is excused if you guys don't have it done for today. It was posted online in Google Classroom. the worksheet itself. You could have printed it off, but I also give you, like the school handbook says, an extra day. You just pass back. Got one, pass back. Anybody else absent yesterday? Yeah, we still have a couple out. Okay. Here we go. We're going to grade, and we're going to grade fast. You guys ready? We're going to grade, and we're going to grade fast. I need my colored pen so it sticks out. Here we go. Okay, numbers 1 through what? 9? Whew, there was a lot. I'm not going to show all the work. If you guys miss them, you can ask me homework questions in just a second. But for number 1, you guys were supposed to solve the equation, solve for the zeros. Number 1, x equals 0 and 5. Number 2, d equals 0 and negative 8. Number 3, t equals 0 and negative 7. Now hold on. What if someone's like, I was absent, or someone's like, I didn't do my homework? If I walk around in a second and if I just see these, what am I going to think?
Cheated.
Exactly. Now, I'm not to say that none of you can do this with mental math, but there are different places on this homework there should be work shown. So if you want to write down the answers to check later, that's okay. But remember, we should always show work. No work means no credit. Thanks, Mrs. McRae. Here we go. Number 4, x equals negative 2 and positive 5. You might have started getting stuck if you weren't showing your work. Negative 2 and a positive 5. Number 5, p equals negative 3 and negative 1/5. Number 6 was weird because there were 2 different answers, but the answers were the exact same, negative 2/3. Isaiah, we're getting them all right, yeah?
Yeah.
Number 7, once again, it was weird. There were 2 with the same answer, but that's okay. That same answer was 10. Number 8, did you guys get all 3 answers? There were 3 answers. 0, good, and? Negative 4, good, and? 5. There were just a few of you that might have forgotten about that beginning one needing to be 0. T equals 0, t plus 4 equals 0, and solve. T minus 5 equals 0, and solve. Hey, this one has how many answers?
3.
Good. 3 here too. U equals, what do you got?
0
And? 9 and?
5/2.
Good. Are you getting, well, are some of you still afraid of fractions, or are you willing to put them down? I understand, but are you willing to put them down if it's the right answer?
Yes.
5/2 is good for me. It's the best answer for me. This one was a little bit hard. You had to see that this was counting by 2s. So 2, 4, 6. Wait, it's back 1. So this one, x equals a positive 5. But if you went the other direction, 2, negative 2, negative 4, negative 6, negative 5. But guys, check it. Isn't that what happens when you set each of these equal to 0 and solve? It's in that nice factored form. Maybe you saw the positive 5 and the negative 5 right here.
Is it okay if I put like x equals plus and minus?
Oh yeah, that's actually a cooler way of doing it. Thanks, Isaiah. There's also this cool little sign in math, plus minus, that means, hey, it's both, the positive and the negative. That's cool. Now what if I was to hide the graph of this one and we were just to look at the equation? Now some of you wrote it down. I know. But if we were just to look at the equation, do you guys know what the zeros would be of this one?
Yes.
X minus 2 gets us what when we solve?
2.
Positive 2. Good. And x plus 4 gets us what when we solve?
Negative 4.
Negative 4. But that's also on the graph. Because we have it hitting at, well, that's 6, that's 3. Oh, that's weird. That must be 2. Oh, yeah, look at the equation. It's 2. And then that's negative 3, negative 6. Oh, it looks really close. Negative 4. Oh, yeah, negative 4 from the equation. Sometimes the graph, it's hard to see what the answers are, so we go looking at the equation to see. All right, numbers 12 through 17. I'm going to go pretty fast. But guys, look at the front board. Don't 12 and 13 and 14 look like the example I have on the front board? Pulling out, yeah, going from a polynomial to factors. Number 12, did you guys pull out a 4t and get t plus 3 left? That's all you had to do. The GCF was 4t, pull it out, t plus 3 was left. Number 13, did you guys get the GCF to be 5k squared?
Yeah.
There was a 5 in common and k squared in common. You had a 2k minus 3 left. I think we might need to go over number 13 in a second. That was a really hard GCF to pull out, at least compared to the other ones. And number 14, did you guys pull out a 4x squared and get 2x minus 5 left? Number 15, sorry. All that was in common was a t, and I had 3t minus 1, which ends up getting me zeros of t equals 0 and 1 over 3. Number 16, there was a 5y that was in common with a y plus 2 left over, which if I split the red c and I set each equal to 0, y equals 0 and negative 2. For number 17, oh, that one's kind of hard, but there was a 3 in common and an n in common. And we end up with 7 plus 4n equals 0. Split the red c, solve, n equals 0 and negative 7 over 4. Don't get me decimals, get me fractions. That is good enough. Number 18, did you guys figure out what was wrong?
Yes.
Okay, they made that common mistake I talked about in class yesterday. It was right here in step number 2. What should step number 2 have been? Yeah, they were good on that. The GCF was 5t, but Isaiah, what should have been left in the parentheses?
3t plus 1.
Yeah, if I divide 15t squared by 5t and 5t by 5t, I end up with 3t left here, but a 1. That's 1. I get a 3t left here, but I have a 1 left there, which means when I go to solve, split the red c and set each one equal to 0. I end up with this one getting t equals 0 after I divide by 5. This one, I get t equals negative 1/3 when I subtract the 1. And some of you are seeing why maybe we should have gone to homework spirals to do work. This gets really messy really fast, huh? But if I kept going, 3t equals negative 1, divide by 3, divide by 3. That's where he came from. So they were totally off on this guy, because that 1 should have stayed when I pulled out the 5t. And then this last one is saying basically like, hey, there's an application to this whole 0 idea. It has to do when the frog leaves the ground and then comes back down to the ground, because a frog jumps in like a parabolic. A lot of stuff in nature actually moves in this parabolic nature, this curved nature. So the frog jumps, comes back down. These points, otherwise known as the zeros, are when he starts and when he stops. And we can find those by coming up here and pulling out the GCF, setting equal to 0 to find those zeros. So we have our frog jumping when he leaves the ground, when he comes back down. I take my GCF out and I say, hey, let's find the zeros. Maybe that'll help me out. So I get x equals 0 and x equals positive 1/4, which means I know the frog left the ground at this 0. And then, well, this must have been 1/4. And there's 1/2 and 3/4 and 1. It's when he left the ground and when he came back. We could even say something like it took 1/4 of a second. It depends on the problem, though, as to what's going on. Oh, no, that's true. Look, x is the number of seconds. So it took him 1/4 of a second to leave the ground and come back. Anyway, I gave you guys not a puzzle time for this section, but a practice one, because the puzzle time didn't have very good problems. It was kind of like lame. I mean, I know the jokes are always lame, but the problems were lame too. Is there any, and I know it's hard, because some of you might have missed multiple things, but is there any one where you're like, I thought I knew it, or I really didn't know how to get to the answer? Yeah, Andrew.
18.
18. Okay. For number 18, let me just do a quick little offset side. Is that okay? Oh, that's more. Huh. There we go. Okay, so for number 18, it gives us, can I just solve the whole thing and then we can find the mistake? Where is it? There it is. Okay. 15t squared plus 5t. Is that what my computer's not working? Me too. I know, guys. It's kind of annoying when computers don't work. Give me 1 sec. Here we go. Okay. Andrew, double check me, but I think I have it. It was 15t squared plus 5t?
Yeah.
Okay. We have to ask ourselves the question, what's the GCF?
5t.
Oh, yeah, you guys can all help us out. GCF is 5t. When I pull out a 5t, I'm dividing, right? If we're showing all the work. Because if we're getting things wrong, we have to show all the work to figure out where our brains are messing up. So when we factor it out, when we pull it out, we're dividing. We're undistributed. Going backwards. Now, some of you, this is hard for your brains to process. And that's okay. I don't mind. I don't mind hard. You can figure out hard. So if it's hard, go ahead and take this guy off to the side and break him down and say, okay, I pulled out a 5t. I mean, 5t equals 5 times t. But then 15t squared, doesn't 15t squared equal 5 times what? 3. So if I'm pulling out a 5t, if I'm dividing a 5t, take away the 5, take away the t, what's left? You see it? Now, careful, we have this 5t in front. But this is where it gets tricky, because if you think, oh, I'm taking it away, a lot of people say 0 is left. But look at the math. If you're dividing 5 over 5, t over t, this doesn't go to 0. This reduces to be 1. That's where they look at their work. That's where they made the mistake. They took out the 5t, and they even got the 3t, but they said, that's 0. It's not 0, it's 1. So then to solve, well, guys, ask yourself the question. Equals 0? Check mark. Factors. Check mark. Now, split it up like Moses in the Red Sea. Well, God threw Moses in the Red Sea. Chapel yesterday. You guys hear it? I heard it. Plus 1 equals 0. Divide by 5, and then Andrew, we're going to get our 2 answers of t equals 0 and subtract 1. Divide by 3. And those are the 2 that I showed today. There we go. Are we good? Okay. I want you to keep out your worksheet. I want you to keep out the 21 through 38. I'm going to walk around and grade as you guys start on your notes. So keep out the worksheet, keep out your homework spirals, grab out your composition book, just put it right on top. I'm going to come grade 21 through 38. I need you guys to start taking notes. So let me steal this title real fast. I'm going to steal it from the warm-up. All right, guys, notes open. Here we go. Sorry, guys. All right, can you see your notes you're supposed to take? I'm going to go ahead and pause the video while I come around on Thursday or Monday. So just come see me if you have some absent work you're able to make up, okay? And then a few of you guys got stuck in different places, come see me as well. So I can try to help, okay? Here we go. So, for section 7.5, we're trying to go backwards. We're trying to go backwards. Factoring. We're trying to go from polynomials to factors, but now we have a trinomial. So, here. I need to ask you guys a question. Do you know how you were just multiplying super well? 5 out of 5, 4 out of 5, maybe some 3 out of 5. But you were doing awesome. This would have been an answer. Ready? This would have been an answer to one of those multiplication problems. Our goal is to figure out what that multiplication problem would have been. Now, check it. If you were doing the box method, wouldn't the x squared have been in this place? Right? Or if you were doing the foiling method, my foiling people actually, you might get a little more confused, so pay super close attention, my mental math people. If you were doing a table, x squared than the first pieces of our factors? That makes sense, right? So x squared came from x and x, focus. So x and x would have been the first pieces of our factors. Remember, factors are those parentheses that are being multiplied together that allow us to do those equals 0, Moses splits the Red Sea. Now, where would 24 come from? Maybe from numbers, right? One of you guys just a second ago was saying like, oh, so when there are numbers, we just multiply. Alexis, I think that was you. You're like, when there are numbers, we just multiply. So 24 would have come from two numbers. So start shouting out, what are different ways to get to 24 from two numbers?
8 and 3.
8 and 3. 1 and 24. 2 and 12. 4 and 6, right? Which one
11.
helps me? 8 and 3. See it? 8x and 3x would have been these other two terms. Because check it, doesn't 8 times 3 make 24? And wouldn't 8x plus 3x give me 11? This fits all the pieces. But then my question is, okay, what must have gone here?
Something.
Close. Oh no, you're right. Would 3 times x have given me 3x?
Yeah.
Would 3 times, wait, what's going to go here? Would 8 times x give me 8x?
Yeah.
Would 8 times 3 give me 20?
Beautiful.
You guys got it. Now wait. Pluses or minuses?
Plus.
Plus. So check it. You just did your first factoring problem where you went from a trinomial backwards to its factors. But what you had to look at was, okay, I'm going to fill in the first box. I'm going to fill in the last box. I'm going to ask myself ready? What factors, numbers of 24 add to be 11? What factors of 24 add to be 11? Now, guys, we've only scratched the surface of this, so to be honest, I'm probably going to make this homework. Which I'm going to show you in a second. You take a picture of on your way out the door. I'm going to probably make this homework not due tomorrow. I'm probably going to make it due Thursday instead. But I'm still going to take a picture. You can start. But can we peek at one more real fast?
Yes.
What if we were trying to think of this one in its table? Question. What would go in this top left-hand corner? What's here?
8.
Now, what multiplies to be 8 and adds to be 9?
1. Sorry.
There's a way of showing it with an X, but long story short, 8 and 1, 8x and 1x would have made 9. So I can say x plus 8 and x plus 1. Here's the homework if you guys want to get started, but we need to do a little bit more practice in order to be able to solve these. So this is the next homework due on Thursday. Bye guys. This is the next homework due on Thursday. We're going to do more practice. Good job. It might get a little longer before Thursday, but not due until Thursday. Polynomials backwards. See you guys later.